chapter is current electricity. What is electric current? Electric current is the rate of flow of electric charge. Electric current, which is represented by the letter I is equal to Q by T, rate of flow of electric charge. The unit of electric current is ampere or coulomb per second. Even though electric current has magnitude and direction, it is always considered as a scalar quantity. So next we have to study Ohm's law. Ohm's law states that at constant temperature, the current flowing through a conductor, which is directly proportional to its potential difference. So that we can write V is directly proportional to I. So to remove this proportionality, here we have to introduce a constant. The constant is represented by the letter R into I. This constant, which is said to be the resistance of a conductor. From this relation we can write V is equal to IR. You can say very important relation. V is equal to IR. From this equation we can calculate resistance R is equal to V by I. When we increase the potential, current increases. But at the same time, resistance of a conductor always remains constant. Then only the metallic conductor will obey Ohm's law. So if we draw a graph between potential and current, we will get a straight line. So if we get a straight line, means it always obeys Ohm's law. Here the resistance of the conductor always remains constant. So here the unit of resistance, which is ohm, or the unit is volt per ampere. So 1 ohm is equal to 1 volt by 1 ampere. This resistance of a conductor always depends on 4 factors. The 4 factors, in short, we can represent L, A, N, T. Here this L represent the length of the conductor, A represent the area of cross section, and N represent the nature of the material, and T represent the temperature. So the resistance of a conductor, which is directly proportional to the length, and it is inversely proportional to the area of cross section. When length increases, the resistance of a conductor increases, but at the same time, if we increase the area of cross section, the resistance of a conductor decreases. To remove this proportionality, here we are going to introduce a constant. That constant is rho L by A. Here this rho is said to be resistivity, or the other name of resistivity is said to be specific resistance. So from this relation we can write resistivity rho is equal to R A by L. This resistivity does not depend on the area of cross section as well as length of the conductor. Resistivity does not depend on the dimensions of a metallic conductor. Resistivity depends on the nature of the material, it depends on temperature, as well as it depends on the number of free electrons. So next we have to study the unit of resistivity. Unit of resistivity is, here you just consider unit of resistance is ohm, unit of area is meter square, unit of length is meter. Here this meter and meter cancel. We get the unit of resistivity is ohmmeter.
If you found this video helpful, please like, share and subscribe to the channel. See you in next class.